Okay, so here, what we're going to do in this example is we're going to decide what intervals the graph of the function here is increasing, decreasing, or constant. Okay, so we have this graph, and so we want to ask ourselves what's happening as x gets larger. So picture ourselves, if we're walking across or if we're going across from left to right, what's the graph doing? What is y doing? What's the function doing, right? So if we walk as x gets bigger, so we're going that way, what's happening to the graph? So if we notice the arrow says, hey, it's going this way, okay? So you could picture if we extend this out, we just extend this out to infinity, right? So it's going to keep going towards negative infinity, but we're walking this way. So how do we describe the behavior of this graph if we go from negative infinity and we're walking this way? Well, it's decreasing, right? It's going down. Again, we always our reference is going from left to right. So what's happening here? Well, it's going down. It's decreasing. So it's decreasing, but to what point is it decreasing? How far in the x direction do we go before something changes? Well, if we notice this point here, negative 2, 1, so at this point here, so if we, right here, so right there, it changes, right? So from here, from negative infinity to negative 2, and again, we're going to use parentheses. We're not going to use a square bracket because we're only interested in open intervals. So on this interval, the graph of the function is decreasing. Okay? Now, it changes at x equals negative 2. And then what happens? Now, as we go, as x gets larger, what's happening to the graph now? It's going up. So now it's increasing. Now, it increases until when? Until we get to here where there's a change in the graph. Okay? Now, it goes from increasing to what? Constant. So, where does that happen? Well, that happens when x is equal to 1. So, here, it changes. So in this interval, right, from negative 2 to 1, it's increasing, right? So in this case, it's increasing. Okay, so it increases from negative 2 to 1. Okay, and then what happens here? Well, from this point forward, off to positive infinity, from x equals 1 to positive infinity, it stays the same. It's a constant function, right? So it's constant, horizontal line, constant. And so from 1 to positive infinity, it's constant. And so what we find is that the largest interval that this function decreases is negative infinity to negative 2. And then the open interval from negative 2 to 1, it increases. So decreases on this interval, increases on this interval, and then from 1 to positive infinity, the function is constant. And so looking at a graph, that's how we would determine the largest open intervals where the function is either decreasing, increasing, or constant. And that's it.